Hello, everyone. Good morning.
Hello, good morning.
Good morning.
Good morning.
Good morning.
Good morning, everyone. We'll keep the meeting recorded for those that will join late or are not able to join today. So today is mostly technical, and everything we're going to do involves a practical. And then tomorrow we're going to move to the practical side of the production system. All right, so we are looking at the CI/CD used for the electronic case-based surveillance system. And when we talk about CI/CD, we just mean the pipeline that we have created for the continuous integration and continuous delivery or deployment. And what that means is that when we talk about continuous integration, we just mean that we want code changes to be merged frequently. So if there is a list of functionalities that need to change, and I work on one functionality today, I push that functionality or that change in the code somewhere, and that change reflects immediately. When we talk about continuous delivery or deployment, it means that we have configured the DevOps part of things such that the integration, the testing, and the deployment of the new changes to production happens automatically, and everything happens immediately without any delay. So with that pipeline, the code will always be ready to be released, and then new features or when we have bug fixes will be delivered quickly. Now, up until now, download the source code for the systems. The reason we have to do this is that the handover phase involves handing over the source code and all of the management of the system to the countries. And so we're going to walk through that process of the pipeline, and everyone will clone their source code, which means that if you want to make changes within countries, you now have access to do that directly by yourself without breaking any setup. So for the ECBS, we use Git for the version control. And Git is an open source version control system that will allow us to manage and keep track of all the source code history. And then we use GitHub, which is the cloud-based hosting service that helps us manage all of these Git repositories. So Git is open source, and for us to start, you all have to download Git if you don't already have it on your system. You go to the site gitscm.com/downloads and download Git for your operating system. Now, you need to have Git on your system to be able to create version control softwares. Git is what you will use to write command that send this code to a repository or somewhere you save this code that manages the different versions of changes that you have made. And it also allows different group of people to work on the same project simultaneously without interfering with each other's development efforts, and also keeps different versions of work that has already been done. And so that if there is a breaking change that was made, you can easily reverse back to how it was previously before the change in the code. So you can choose what version you want to implement when code is changed frequently. Does anyone have questions? All right. So once you have Git downloaded and installed on your system, you want to check to see what version of Git you have and how this is working. For this, we need a tool, and we need a command line tool. All Mac systems have Terminal, which is a bash shell command line tool, which is good and perfect for the use case. But Windows has PowerShell, which might not give you the desired effect. So for Windows, you might want to download Commander, extract the zip file, and now use the app as your bash shell to interact on the command line. Now we're going to be using command line. You can't work on servers without command line, or work on this kind of project without using the command line. And so if you are using Windows, you want to download the Commander app. If you're using Mac, Terminal is good enough for the use case. Okay, so I can go to my system and open Terminal. And on this Terminal app, you want to check if Git is installed. You can just type Git, and it will give you frequently used Git commands. This shows that you have Git. You want to check the version of Git. You can say Git version like this, and it should give you the version of Git that you have installed on your system. Also, you want to check where the directory where Git is installed. I think for Windows, you might use where.exe like this, But for Mac, you just use widget, and it tells you the directory where Git is installed. So these are the basic things you do on your command line. So if you are using terminal, you do this on terminal. If you are going to be using the Commander app, it's going to present in the same way, and then you just type at the prompt what you need to work on. Or to even make it better, in countries where the IT team have different operating systems, some will have Windows, some will have Mac, some will have Linux. So what you can do is to download Visual Studio Code. So we can go to the site and get Visual Studio Code and download the version for your operating system. Now you need Visual Studio Code for two things. It has a terminal that you can use, and it also has your code editor, which you also need when we want to work on this source code. So you can head over to code.visualstudio.com and then download Visual Studio Code for your operating system. Install the Visual Studio Code. So these are the things you need to download and install to set up your development server, and then to be able to generate keys that your development server can communicate with the repository to be able to push and pull codes and changes from the repository. Now take note that any system that you use to configure all of this, to install this, is going to be the system that the source code resides. It's going to be the only system that holds the public key that you can use to communicate with GitHub to get the source code. So if you have a work system where you want these things to reside, then you want to do the practical on your system, go back to your work system and repeat the same steps. So the first thing you want to have is your code editor. For Windows, you want to download Commander. Windows PowerShell will not give you good effects. So you want Commander for Windows. If you are using MacBook, terminal is fine. You can use your terminal the way it is, or you can just keep downloading anything and just go to download Visual Studio Code, and the Visual Studio Code editor gives you a terminal that you can use that makes it easy for everybody to have the same command and have the same experience. So if I go to Visual Studio Code, what I will have is, so when you open Visual Studio Code, let's assume I don't have any project here. When you have Visual Studio Code, you have a terminal at the bottom here. And this terminal just acts exactly like what we just looked at when I used my terminal here. So you can come to this terminal and type any command line code you want. So once you install Visual Studio Code, you don't actually need to have terminal or commander. You just use the terminal you have here, and then you can type your code above. Does anyone have any question? Is it understood so far?
Yes, it is.
Okay. Yes.
All right. So once you have your code editor, which is something you will need to have a development server, so either on your work device or on your personal device, whatever you use to manage your systems, on that device you want to have Visual Studio Code. It's not compulsory you have this. You just need to have a code editor, and you need to have a command line tool that can run bash shell commands. And so once you have these two things, the next thing we want to look at are the dependencies that the project depends on. Now, eCBS was created using PHP at the time, and it has evolved over time to actually have Python. So we have microservices that uses different language. PHP was a scripting language. We use other languages, HTML, CSS, JavaScript, and other JavaScript libraries like jQuery, Ajax. There's a whole list in the technical documentation, but we'll look at the back-end languages, PHP, Python. And for us to be able to work with these languages, PHP needs you to have a server running on your local machine. And we can use XAMPP server, which will be uniform across operating system. Instead of using MAMP or WAMP, you can go to apachefriends.org to download a server version for your operating system. You want to try to make sure it is the latest version of PHP 8.2.12, and you download that. You need to have this server running for you to be able to have the source code running on your system. So I'll go over it again. You either go to code.visualstudio.com and download Visual Studio Code for your operating system, Windows or Mac, or you want to have any code editor you want to use, you can use your Notepad for Windows, TextEdit for Mac, or you want to use Notepad++, Atom, any code editor that you prefer. And then when you have the code editor, you need to have a bash shell command. Line 2, if you are using Mac, Terminal works fine. If you are using Windows, you want to download Commander or anyone you know of that can help you run command line. So if you have Visual Studio Code, you don't need to download this, except if you just want to have it or try it out. Once this is done, you want to have Git downloaded and installed. If you are not sure if you have Git, if you have Visual Studio Code, you can come here to type Git and see if you have Git. You have the commonly used Git commands. Use it like this to show that Git is installed. You can also use another like Git version to see the version of Git that you have, or you can use with Git to see where it is installed, directory of installation. Once you can find all of these, it means you have Git installed. You don't need to download and install it a second time. Is it clear?
Yes.
Okay, so we have Git. The next thing we want to do is to have a GitHub account. Either you have a GitHub account, one for the IT department for the country. If you already have one, you don't need to create a new one. If you don't have one, if you have a work GitHub account, you need to have a personal GitHub account. You just need to have a GitHub account that we can use to transfer the source code to you. Now, you go to github.com and create an account. This, I'm already logged into an account that was created. The OECS has a repository where all the source code for the project goes to. And all of the project source code are named according to the country names. So when you go to github.com, create your new account for GitHub, and then we're going to use that account shortly. Now, the Git will allow everybody to work simultaneously on this system, and for you to be able to manage the system, you need to be able to connect to this from your command line, from your system. You need to be able to push code to this system. Your servant should be able to communicate with this system and be able to pull code for the system so that things are done automatically and not manually. And so there is no downtime, like saying things like system cannot be used for the next 2 weeks because you need to do an update. No. If you have a CI/CD pipeline, everything happens in a split of a second, even while people are using the site, without anything breaking or stopping, because you have a pipeline where you push all of your code. If you push to pilots and it's working fine and it's tested and it passes all the tests, you now pull to production, and automatically all the changes are in production without breaking anything or without stopping the usage or without no downtime. All right. So we use the GitHub as the version control system to host all of the source code repositories. And so each of the countries have 2 repositories, one for pilots, one for production. Up until now, your repositories are private, which means that you only access this repository if you are added as a collaborator. It is not public for the world to see. At the end of the project, the OECS will decide if they want to stop paying for private repository and downgrade to public, which means that everybody can see your source code, see your directory structure. You decide if you want it that way or you don't want it that way for private and public. So that is a different discussion that will be in your handover notes. Being public has no problem. You can make it public if you want to have a team of different developers outside, volunteers to work on your source code. You just need to protect your main branch to make sure that no breaking changes goes to the main without any authorization. So everybody makes a pull request, and once properly tested, you now want to push to your production. We're going to look at all of that practical, some today, some tomorrow. So I'm talking about repository. And when we say repository, it just means it's like a store where we store the code. So if you have a repository, it's like a house that houses a particular project. Then we'll have another repository that holds another project. This repository are named. So I can say I'm going to the repository for Dominica. And maybe I had named when I created the repository, I named it Dominica, or I named it Antigua, or I have a repository. You can give any name you want to your repository. It just means the house. Or let's look at it like a file structure, the folder. It just means the name of the folder that holds the project. That's what it just means. But it's called repository in terms of version control. And then we have something we call branch. And when we say branch, it just means that you have different versions of the same source code in the repository. So let's say, for instance, I make a change today, add a new functionality. I save it in a new branch of the repository. So it's like you have a tree standing, and then there are several branches on the tree. They all belong to the same tree. They're feeding from the same root, but then you have all different branches. So if it's a tree that bears fruit, then you can say some branches have more fruits than others, so like functionalities than others, and you choose what functionality you want from each of the branch. So that's the plain definition of what the branch is. So the source code repositories, I'm going to just explain the repositories for the countries. So we have a repository for both pilot and production. Now, because we didn't use, yes, someone put in the chats, you can go ahead and ask your question, Harriet.
Okay. Hi, good morning, everyone. Good morning, Mildred. Sorry, I couldn't find the hands up thing. So, and I didn't want to just speak randomly. I want to, first of all, I'm not going to be able to stay for the whole training. I have the public speaking competition to go judge, so I have to go run off to that. Secondly, we have our own Git lab here in St. Vincent, and I would like to pull the codes down to it. I'm not so sure I'm in a I would like to pull the codes down to it. That's fine?
Yes, that's fine.
Okay, so is it okay? Can I do that tomorrow?
Yes, we will do all the cloning tomorrow, but today you can just create your own private account, so just know how to pull that. So
well, I have a GitLab account with my gov.vc email.
Okay.
So is that okay?
No, create a GitHub account.
What do you mean?
So go to github.com.
Yeah. So I have an account here already with my gov email.
Okay, so that's fine. You can use an account that already exists.
Yeah. Okay, right. So so I have that, and then I just to pull. Okay. Yes. So the account is my same email, hk.gov@gov.vc.
Yeah. So what we'll do now is, once we just get to the practical, I'll try to keep this within an hour, under 2 hours, so that everybody can have a chance to go and create and download and install anything we need to do, and then we'll do all the pulling tomorrow.
Okay,
so
great.
But in a short while, I'll ask everyone what I need to be pasted in the chat for me to copy and add, so you can have access to the repository. But before then, you will not be able to have access to the repository without SSH keys, which we'll have to generate on our systems to be able to access this system. Okay?
Oh, okay. I don't know that I have like a SSH key.
No, we'll generate one.
I know, but I didn't. Is it possible I could just use the Git download, like the manual?
If you download manually, you are not going to be in the chain of pull and push to the pipeline. You are going to be having a local copy, and there will be no connection to the repository. If you clone the repository, then you have direct access to the pipeline, which means that from your system, you make any change. Let's say, for instance, you want to put the government logo on the home page and change the OECS logo out of it on the home page. You put that, you can push to your repository and pull to production. It's automatically there. If you download a copy of the system, it means it is completely out of it. Whatever you do on what you download is not going to reflect on your system, because you have a totally different copy that is not in the pipeline.
Okay, I understand. It's not that I wasn't objecting, it's just that things are a bit rushed here, so I was trying to avoid it for now, but I understand. So I'll go through the process.
Okay.
Okay, thanks.
All right. Okay, so we'll start in alphabetical order, and we will look at the repository for Antigua and Barbuda. Now, for production, the repository for Antigua and Barbuda is ANU-CBS. That's the name of the repository. It is in the OECS account. So this is the site for Antigua's repository. It will be in your documentation. You can copy it if you want, but when you receive your documentation, you will know where your repository is on your system. And I think you already have it in Output 2 reports if you got it. So this is the repository for production. So which means that whatever goes here is what affects your live system. We have another repository for pilot, which is the one we use for all the practice. Whatever goes there is what affects your learn site. So that is named Antigua. So you have two source code repositories. We use one for pilot and one for production. Now these things were created long before we had GitHub Actions, where we could actually have the different pilot, production, and automatic once there's a push to GitHub Actions. And again, it might be complicated for the countries, so we use the simpler step of having two separate repositories for pilots and for production, so that you will send your code to, you have access to both. You send all of your changes to pilot. If it works well, you copy and paste it in production, and then push also and send. It's a bit of a longer step than using GitHub Actions, but this is the simplest and the most basic that I think you'll all be able to work with. And I think it won't even involve subscriptions and payments. So we try to make things as manageable as possible. So we have repository for Dominica. Dominica is named DOM-CBS for the live site and Dominica for the pilot site. Okay. Then we have for Grenada, which is named GND-CBS for the production site and Grenada for the pilot site. Then we have SKB-CBS, which is the production for St. Kitts and Nevis for the pilot for St. Kitts and Nevis. Then we have St. Vincent and the Grenadines. We have SVG-HIVMS for the production site, and then we have Vincent for the pilot site. So all the repositories for each of the country reside in the OECS here. So for each of these repository, you will have access granted differently. Now, before we can even have access to this repository, your system, your computer needs to be able to communicate with this repository in a secured way. And then we're going to do that using SSH keys. You can actually clone using HTTPS, but we want to use SSH. We'll do the first practical today, and then tomorrow you have an idea. You can work with your work device, the device that you want to connect, and then we'll do a proper connection to the production. But now you can use any device. We're just going to be working with the pilot, and then you can repeat it privately, or we do it tomorrow when you have all of the access and the devices you want. Now we use the command line interface for interaction between the computer via text command like this. I'm not going to use Visual Studio Code. I'll try to use Terminal just so that we can make others to be able to work with this if they choose not to have Visual Studio Code, but it's the same command you type in the terminal of Visual Studio Code. So we have a shell. We call this a shell where we type our commands, and command line is just the fastest way to access file and systems and servers. There's no best way to save that. People that have different kind of softwares they use to check their TCP, IP, and all that. I'm a bit old school, and I think I work faster doing things on plain sheets, and you will enjoy using plain sheets than using all those apps and third-party systems. So you want to write your commands yourself. You want to be able to know the basic commands to run. It makes things easier and faster. We'll look at some common command for those that are not used to using command line. Command line helps you to be able to access things faster and do things that you don't know you can actually do with your system. So I want to know what directory I'm on the system. Now every system has a file structure. If you have folders, you have your desktop, you have documents, you have downloads folder. In those folders are different files. You might not want to go to your file system and click and start looking for what files all the folders contain. You can come here to look at them. Let's say I want to look at my current directory. I'll type pwd and it tells me this is where I am on my system. I'm on this part of the system. Let's say I want to go to desktop, for instance. So let me do cd desktop. This will change to desktop, and this is for Mac. For Windows, you'll be on a different directory, but it's basically the same command. You cd means change directory, and then the name of the directory you want to go to. And once you're in that directory, you can use ls, which means list, to see all the files that you have in that directory listed out. If you want to see even the hidden files, you do this LA or AL, and it will show you hidden files. Hidden files are files with a dot in front of it. Okay, so these commands will help you to be able to work with the system. Now you want to create a new folder. You will use make directory and then the name of the folder you want. Let's say I want to create a new folder called, let's say, CI/CD. That's my folder name. I created this on my desktop. So if I come here to my desktop, I should see that new folder I just created here, the named CI/CD here on the desktop. And I can open this to see there is nothing there. If within the same directory I want to create a file, I'll first of all cd into that directory that I just created. Let me clear so I can go up for you to see. So I'll cd into the CI/CD, and once I'm there, I can create a file by using, let's say, touch and then the name of the file. Let's say I want to create a file that is a text file, for instance. We know that files have extensions. If you have a Word document, you see .docx. If you have PDF, you see .pdf. So different extensions. So I want to create a text file, and I will say touch. Let's say I want to create a file named example.txt, and I have this file. When I list here, I see I have a file called example.txt here. Now, if I want to write to this file, example.txt, I can use a command line text editor or command line tool called nano, and I'll say nano example.txt. Something about nano is that if you don't have that file, you just name it to create it. If you have it, it will open it. So when I get here, I can type whatever I want to type here. Let's say this is an example file. So if it's a file that you have code in, you put the extension. So for PHP with .php extension, for Python.py, something like that. Then you Control X and then you type yes, and then you save this file. So when you come back the next time and put nano example.txt, you will find what you typed the last time. You can keep typing to edit. Okay. Now the reason we are doing this is that these are the things that you will need to work with when you work with your source code. You need to be able to know your directory. You'll be able to change directory to any directory you want. You should be able to see all the files you have, including hidden files. You should be able to open the files on with a command line and have a command line text editor like this. Let's say I want to copy the content of the example.txt file. I'll use cat example.txt, and then it gives me the content, and then I can copy it and paste it wherever I want to copy. I want to paste. So we've seen this basic command. Now let's use this command these commands we've looked at to get our SSH keys to GitHub and be able to clone our source code. Before we do that, let's see how we can remove the file. Now I'm done with this. It's an example folder. I don't want to have it on my system. I might want to delete it. If I want to delete it, first of all, I have a file called example.txt. Let's say I want to delete a file. I can put remove example.txt like this. When you use remove, there's a flag you can call the I flag like this. And when you use an I flag, it means you want it to always give you a confirmation message for you to not accidentally delete anything, so that you recheck or reconfirm that yes, you really want to delete this. There's also a flag, recursive flag, and this when you have, let's say you are deleting a folder and the folder has several files, and it begins to ask questions for you to confirm each of the file. Maybe it's a folder that have thousands of files. You don't want to keep answering all of the questions of, do you really want to delete this file? Click here, so you do that 1,000 times. You use the R flag for it to just recursively delete everything without asking you questions like that. So let's say I want to remove the folder. So I will go out one directory, which means I want to go back to my desktop, because on this desktop I have my CI/CD. So I want to remove, I'll use recursive, and I'm removing CI/CD folder from my desktop, and it's all done. So we've seen how to run these basic commands that we will need shortly. We want to now see what we need, how we need to connect to the repository for us to be able to clone the system. Now, I said earlier that we have PHP for parts of the ECBS system, and when we use PHP on our local machine, we need to have a server running on that local machine, and we are going to use XAMPP server. You can use any server you want. If you have MAMP, WAMP, whatever you want to use, but XAMPP makes it uniform across Windows and Mac. So you download XAMPP, you go to apachefriends.org, you download XAMPP server for your operating system. Try to download the one with the latest version of PHP 8.2.12. And once you get this downloaded, you want to install it. Once installed, the directory for files on the server is the htdocs directory, and the htdocs is in the XAMPP folder. So on Windows, I'm not so sure how it will display on Windows, but on Mac, when you come to applications, I think Windows, you go to your C drive, then you go to XAMPP, and then you go to htdocs. That is the file system. And then in this directory htdocs is where you clone all your projects. So you find your project folders the same as the name of your repositories. Anyone question? So once you have that, let's navigate to the directory. So on your system, once you are in a particular directory, I'm in my desktop, I need to leave my desktop to go to another directory. So I want to cd, I can put a / to know that it's starting from, it's not going to look from this directory desktop, and it's in my applications. So for you using Windows, it's not going to be in your applications, it's going to be cdc / XAMPP or users, wherever your XAMPP folder is. So you have to check your C drive. Once you install, I think by default for Windows, once you install, it goes to your C drive. And then on your C drive, you look for the XAMPP folder. On Mac, you see applications / XAMPP, right? And once you are here, you can list to see where you are. And then you see that we have a htdocs folder. All of the files that Apache is going to run must be in the htdocs folder. And now I can cd into htdocs. It's in this folder that you want to create any new folder you want. Let's say you are building a new system, or you want to create a new microservice that your system will work with. You're going to create that folder here in the htdocs directory on your system. But what we want to do is clone our source code to our local system, where we can make changes and be able to push through the same pipeline for it to be able to update the repository and pull into all the servers. There's no automated push and triggers a pull to the servers. We want you to manually type git pull so that you decide what version of the system you want to use, or you want to make sure that this has been tested. I want to now create a trigger to pull to the production server. Once you are here, we can clone. But you can't just run git clone. It's not going to communicate with this. For you to use your Git, okay, first of all, once you create this, once you install your XAMPP server, first of all, you want to start the servers. And so here I'll go to my XAMPP control panel. And for the control panel, you go to your manage servers and make sure that you have Apache web server running and MySQL database running. Now we use MariaDB for the relational database management system for ECBS. And so you have to have MySQL running to work with MariaDB. So you have to make sure this is running. If it stops like this, you click on it and click start to make sure they're running on your local machine. Once this is running, you can come to your system and type localhost. Once you type localhost, you should be able to see something like this: XAMPP, Apache, MariaDB, PHP, Perl written. If you don't see this, it means that it's either not started. Check if you have any error message, or you don't have it installed. So you want to make sure it is running, and when you type localhost, it gives you this dashboard. Now, when you are there are two things you can log onto: localhost / your project name. So I have my project here, CBS5, or I have the project, I can say Antigua. I have all the folders already cloned. So I'll use CBS5. Let's assume I don't have them cloned yet. And then it will just come open the site. So this site is going to run on your local machine, like you're running live, but just that everything is on your local machine. You want to control the database, you do localhost /php myadmin. Now in your output 2 report, it states what the database name is. So the database name is country for this trial system. And so you want to make sure you have country created. If you don't have country created, it's a time for you to come here and create a new database. And you put the name of the database. let's say country, and then you want to make sure the collation is UTF-8 Unicode CI. If this is not your collation for the ECBS, the tables and the columns are all UTF-8 Unicode CI. What happens is that your foreign key begins to have errors. Sometimes when the collations are different, you begin to have issues of the child and foreign key conflict when you try to update or delete a particular row of information that is a child or that whose table is a foreign key of a parent table. Then you begin to have collation conflict like that. So you want to make sure for ECBS is in your documentation, your database name is the name of the database you have specified in your environment file, and then your collation, you can check the table definition in the classes file to see the collation of all the tables. If you are trying to reinstall or re-implement ECBS, you are relocating your servers out of where it is built, you want to change things around, you want to make sure that you create a database, name it whatever name you put in your environment file. It can be any name you want, just make sure your environment file has that name. And then the collation, whatever collation you use here for your database, make sure you change the table definition collations in the classes file. All of the code that creates the tables are created. You want to make sure that you change the collation to be the same collation with the database, except if for any reason you want to have different collations. You have to be aware of what you're doing. So why we use UTF-8 this is because for different languages and symbols, we have several symbols that can cover different languages. And so in the events that you have client's name, for instance, that have diacritical marks, and you have like some Spanish names or some names that are from some ethnic groups that are not English names and have different kind of characters, then this can cover and take those alphabets because we are using a collation that does that. Let's say one of the islands is a Spanish-speaking island, and you want to have a collation that can account for most of the characters and symbols of that language. Then that's when you change your collation to that. But as long as we are using English, you want to prefer to use this and be able to accommodate majority of the symbols and signs from other languages. Is it understood?
Yes.
Yes.
Okay.
Yes.
Okay. So I will just recap again before I go further. You have your code editor, Visual Studio Code. If you don't want Visual Studio Code, you can use any text editor of your choice. Make sure you have a bash shell command or a console emulator for Windows. For Mac, you can keep using Terminal. Terminal works fine. If you have Visual Studio Code, then you can just use the terminal on Visual Studio Code without having to have any bash shell command line. So we looked at all of the commands that we can run, basic command line codes. We've said that you need to install XAMPP server or whatever server you want to have on your system to be able to run a local server to be able to test the source code on your system, because it uses PHP. Once you download and install XAMPP or whatever server you're using, you have to take note of the directory where the web files are run from that for that server. For XAMPP, it is in the htdocs directory, and you have to go to your C drive, go to XAMPP, then htdocs. For Windows and for Mac, you go to Applications, you go to XAMPP, and then you go to htdocs. It's in the htdocs directory. Once you're in htdocs, that you can create all your files or all your folders for your project or your web pages. And it's in this directory that we're going to clone our systems. So now let's first of all look at the technical setup and then generate our keys. For the ECBS, for the setup, the pipeline is set up like this. On my development server, I have a folder called ECBS. On this server that has this folder, I have generated SSH keys. When you generate keys, you have a public and private key pair. Now, the public key is the key that you share with other systems, where the systems can now securely communicate. The private key is the one that resides on your system. Whenever you use that public key on another system, it verifies and checks your system for the private key, for a matching private key. If it matches, then the link is established. If it doesn't match, it's just restrict your access and says public key. You say access denied, public key. That's the reason you will get. Once we have these keys generated on the system, the next thing is to send this key, the public key, to the GitHub account. The GitHub account must have the public key of the system that is trying to connect to the source code. Once it has that public key, and you try to connect to that account, or you try to push the repository, you try to make any updates to your system, it checks the system you are connecting from. If it has a matching private key to that public key, then the connection is established and you can start any remote access that you want. For the live server, again, for me to be able to log on to the live server for my system, I need to have the same SSH keys, whether the same one, different one. People generate different keys for different systems. But I have to have a private key that matches the public key. That public key has to be on that server, and the private key will be on my system. The server also needs to have keys generated on the server. The public key will be on the GitHub, and the private key resides on the system. So whenever you want two systems to securely communicate, you need to have keys that links them, that establish a communication. So the keys is just like an encryption method to keep things secure. Anybody? Then once we have that structure established, then the communication can start when we make all of this go on GitHub. So this is what the structure looks like. Everybody, you can have 10 developers within the countries, 10 IT staff, all of their systems have their local server installed, which is just like the XAMPP server. They have SSH keys. All of these keys, we put them on GitHub. GitHub now is able to communicate with their computer. So which means that your system can securely send a message to the repository. That means push code. You finish working for the day, you store your code on GitHub. GitHub has the code. The live server, which is the production server where the live system is, can now communicate with GitHub and get the updates from GitHub and update the code here. So this is how the structure is for the whole setup. Does anyone have any question with this setup structure? Okay. So now the next thing we need to do is to generate our keys. So we'll generate keys here. Let's make this a trial key. After this training, you delete the key and then you recreate the same key. Because this is recorded and it's going to be distributed. Once you show your key, you already compromise your system. So we're going to use the key just for practice here, and then you can now delete and repeat the same process after, and don't use that key for production. For you to generate your SSH keys, and when we talk about SSH, we just mean secured shell. There are different key algorithms that we can use. You want to specify what key algorithm you want to use. Majority of the people use RSA keys. You can research what RSA is. There are more secured key. There's a more secured key than RSA. You can specify whatever you want, but we will generate one using a basic method, and then I'll show you how to just generate one and let all of the default values be used. First of all, when we use key pairs to authenticate the user, so that the user or the process that wants remote access to the system, the SSH protocol runs on port 22 by default. Now, because everybody knows it is port 22, it is very common. Port 22 is very common. It's one of the most attacked ports, because they now know that this is a target for brute force attack. Everybody knows that SSH, you can communicate with remote systems, and it is on port 22. So what most people do is to maybe disable port 22, close it, or put whatever firewall on port 22, or just decide to make sure that they choose a port with a less predictable number for the live server. Use that port for SSH. Okay. So if you want to generate SSH keys, you will do SSH keygen, and then you will type, let's say you want to have, you can just do SSH keygen and it's just generate a key for you using all of the default algorithm and the type. If you want to control what algorithm you want to have, and you want to have your email address, you put SSH keygen T here to specify the algorithm you want. Let's say I want RSA key. You can also have a B flag to specify the bytes you want. Maybe you want 40, 56 or something. But you can just do SSH keygen C RSA, and then you put a C flag to type your email address, for instance. So once you type this and put enter, it will ask you that to select the name you want for your key file. By default, your name is ID RSA. Now you want to be very careful with this name ID RSA. If you're using your work system, there's a possibility that you already have ID RSA generated, somebody using a default name, which means that that key is already used to communicate with one remote system. You don't want to overwrite it. So you want to just create your own key. Let's say I want to have ID. Once you put that name in, you can now enter. And then, although SSH keys, RSA keys are very secured, you might want to put a passphrase so that anyone who wants to, let's assume you're still on port 22 and someone wants to run a brute force attack, you want to have a passphrase to make it like a password to make it even more secure. So you can put any password you want for your key so that when anybody tries to use this key, they need a password also. So you type the same password again. And then once you have that, you will see the location where it has been saved. So the public key is called, so I made a spelling error in what I type, but this is where it is saved in. Okay, and I want to get this value now. It is C users. I'm going to copy this. I want to cd /users.ssh directory. It's a hidden directory. Once I get to the directory, I'll see .ssh. I can list to see all of the keys that I have generated here. I have ID RSA.pub. Now, and I'm going to list. So I have my ID RSA.pub. You want to make sure that if you're generating your keys in this directory, your keys will always be in your .ssh directory, and the keys you generate should be here. The one I just generated was not here, is part of my security settings, but you will find your key in your directory. So on your Windows file, I think you go to cd /c/ your user or whatever /.ssh. I think that's the directory it is, or you can just search to find where your .ssh directory is on your Windows. If you don't have it, you create one. Okay, so let's assume that I'll generate a key here. I don't want to expose my key. So let's say, so I have the new one I just generated with the name ID ED25519. This is not an RSA key, but this is the key I just generated. Now, because I have this key, I can now copy this key. Now it has a private key and a public key pair. I want to copy the public key. This private key is what will authenticate. Whatever system that tries to communicate would want to look for the private matching key for this public key. The public key is the key that you share with other systems. Let's say you want to be able to remotely access another system. This public key must reside on that system for it to look on this system for the private key. The same thing with the server. You want two servers to be able to communicate. You want each server to hold each other's public key, and while their private keys reside there. And so when they try to communicate, it tries to authenticate looking for a matching private key for that public key. And once that match is found, then the connection is established. We have this key and we want to connect to GitHub. We'll go to cat. We'll do cat to copy the key, and we'll copy ID ED25519.pub. And once you do this, you copy the key. So if you use the first method that we did with SSH keygen and you specify the algorithm RSA and you put your email address, you have a longer key than this key with this key algorithm. This is not an RSA key, it's a different algorithm, but you get the idea. You copy this key, and then now it's time for us to establish a communication between your system where you want to clone the source code and GitHub. Now on GitHub, the administrator now, to give you access, will now have to come to settings, which is what I'll have to do. I'll come to the avatar first, then I'll go to settings, and then I'll come to SSH and GPG keys, and then here I'll say new keys, and then I want to put a title for the key. let's say SSH training, for instance, and then I'll paste the key here and add key. Once this key is added, then I can now test the connection. I don't want to add a new key here. I already have a key. So what you will do now is, if you are following up and you have created the key, just paste your key in the chat and I'll add your key here so you can establish the communication with your system. We'll still repeat this process tomorrow for those who are not here, for you to be able to clone. This is the only way you can clone your system and maintain the CI/CD pipeline that exists. So anyone has the key generated, just put it in the chat and I will paste your key here for you to be able to clone the system. All right, so if you do follow this process later and you generate the key, you can send me an email for me to add the key to the repository. If not, we can do it during the session. I think it will be better for you to send the key privately in an email to be added so that you don't expose your keys online to communicate. But we need that key first of all to go ahead. Once the key is done and is added here to the GitHub account, we can now come to the command line to see if this key actually, the connection is established. And when you want to test the connection, you type ssh t git at github.com, and then it will ask me for the passphrase of the ID that I have, my RSA key that I have on GitHub. And then once you put your password, so that means I set a passphrase. If you have a passphrase, you have that passphrase, and if you have this hi your username, then you have successfully authenticated, but GitHub does not provide shell access. Once you see this, you have successfully established a connection, and now your system can communicate with that repository or that account that you have connected to. Now, because I am connected, I can now navigate to my htdocs directory, and in this directory I can now come here to say I want to go to the repository where I want to clone. So I have this repository here and I want to clone this repository, for instance. When I come to the repository, I'll come here. I have SSH. I'm using SSH, so I'll just copy this. If you want to use HTTPS, you want to, but let's try to use SSH. Go to SSH, copy that, and then here in the directory, I'll type git clone, and then I'll type the code I just pasted, the link I just pasted, and then you enter, and then this is going to clone this. Now I already have a copy of this. I don't want to reclone it into this directory. You can clone to any directory, but then your local file, your local host is going to be looking at htdocs to run whatever project you try. So once you clone this, then you now have a folder named the name of the folder here, which is Antigua, in your htdocs directory. And you can confirm by just listing to find out that you have the folder, and then you see that you have the folder there, which means that you can now come to your site and do localhost/Antigua to test the system. So you can now see that the system runs on your local server on your machine. So once you are here and the system is cloned, this is the time where you can come to your code editor. And let me go to the code editor. So let's say you're using Visual Studio Code, for instance. You can come to your code editor now and now decide that you want to add the project folder. So I'll come to File, Add Project Folder to Workspace. I want to go to my htdocs directory and I want to add the Antigua file here. So now I have the source code and I want to be able to work with the source code. So here I have the source code. I can come here and make changes to the code, and once changes are made, I want to make sure my terminal is on Antigua. So I'm getting new terminal. Once I make changes, I can now run basic git command to now have different versions. So if I make a change here, I can create a new pull request and send it to GitHub, and then once the branch is working properly on the pilot site, I can now pull it to production. We're going to look at that command to make changes, push to the repository, and pull to production. And so the pipeline creation is already complete now. You already have your system connected to the pipeline by just doing this. Another step we need to look at again, and this is in country, so I don't think you need that step from me, like being able to remotely access your servers. You're within the country, so you can access your servers directly by yourself, but you need to be able to access the server from the command line, in case if you are working and you want to see what is going on different servers, or you want to pull changes to the server. That is one thing that we're going to look at tomorrow. Okay, so I'll try to make this video available. If you know whoever is within the country that needs to be able to clone the source code, they have to be here to clone their source code. Otherwise, after this training workshop tomorrow, you have to contact the OECS to get your source code. Tomorrow is the last day for all of these, and the consultancy will be over, and so I will not be obliged to repeat this process with anyone at the end of the consultancy. So they can be here to clone the source code or contact the OECS after to get any information that have not been gotten. I will leave with the OECS.
Okay. Thank you.
Okay.
All right. So thank you, everyone, and we will meet tomorrow.
Okay.
Thank you.
Bye.
All right. Thank you, everyone.
Thank you, Mentor.